Welcome back to the Art and Science of Computer Technology. Today's lesson will be covering Python collections. Collection data types: dictionary, list, set, and tuple. Dictionaries are unordered, changeable, and indexed. No duplicate members. Lists, also known as arrays, ordered and changeable, allows duplicate members. Set, similar to math, unordered and unindexed, no duplicate members. Tuple, ordered and unchangeable, allows duplicate members. Lists. Lists can contain items of different types, but usually they are all the same type. Lists support concatenations. Unlike strings, lists are mutable types. Append method to add items to the end of the list. Lists versus dictionaries. Lists are ordered, starting at index 0. Dictionaries are unsorted, no guarantee of which items are in what order. Lists are accessed by index, such as items, square brackets, 2. Dictionaries are accessed by key, such as people, square brackets, Leo. One versus multiple dimensions. One-dimensional lists, also known as one-dimensional arrays. Vector list gets assigned a list containing the values 1, 2, 3, and 4 in that order. So the 0 index would be this 1 index would be 2, 3 would be, so vector list 0 equals 1, and then so on and so forth. Multi-dimensional lists, also known as lists of lists, multi-dimensional arrays, or matrices, similar to math. So for example, matrix list, all this stuff over here, and then in order to reference this one in particular right here, it would be matrix list 1, 1, because this would start at 0, so inside of this would be the first array, this would be the second one, this would be the third one. So since it's 0 indexed, you start 0, 1. So 1 would reference this whole thing right here. That's what this one's referring to. And then to get to the other one from right here, you would count 0, 1, which would get you 4. Lists. Clear lists with list name, square brackets, colon inside, gets assigned this. So you'll see this a lot as well when dealing with ranges and splicing and all kinds of stuff like that. Delete lists with del, keyword del, and then the name of your list. List methods. List append x, add an item to the end of the list. List.extend takes an iterable, extend the list by appending all items from the iterable. List.insert ix, insert the item at the given position. So this would be the index, and this would be what you're inserting. List.remove x, remove the first item that's equal to x. So whatever you pass in, the first encounter that you find, that one's going to be the one removed. So if you have duplicates, whichever one's the first one, that would be the only one that gets removed. List.pop takes I. Remove the item at the given position in the list and return it. If no item is specified, the last item is removed and returned. So you'll see pop a lot with dealing with stacks and all kinds of stuff as well. So we'll use that plenty, and you'll be able to figure out pretty quickly probably. List methods continued. List.clear, remove all items from a list, equal to what we just saw with del list with this. List.index x, optional start, optional end, return index and list of first item equal to x. Index returned from 0 index of list, not the start index. List.count takes x, return the number of times x appears in the list. So if you have the word cat appear 20 times in your list, this would return the number 20. List.copy, return a shallow copy of the list, equal to this right here. List methods continued. List.sort, key defaults to none, reverse defaults to false, sort the items of the list in place. List.reverse, reverse the elements of the list in place. Dictionaries. Unordered. Changeable, mutable, can be mutated is what mutable means, so changeable. And indexed. Dictionary methods. Clear, removes all elements from the dictionary. Copy, returns a copy of the dictionary. From keys, returns a dictionary with the specified keys and values. Get, returns the value of the specified keys. Key. Items, return a list containing a tuple for each key value pair. Keys, returns a list containing all the dictionary's keys. Dictionary methods continued. Pop, removes and returns the element with the specified key. Pop item, removes and returns the last inserted key value pair. Set default, returns the value of the specified key. If the key doesn't exist, then insert the key with the specified value. Update. Updates dictionary with the specified key value pairs. Values. Returns the list of all values in the dictionary. Sets. Unordered, unindexed, written in curly brackets. Set methods. Add. Adds an element to the set. Clear. Remove all elements from the set. So pretty much just empty, clear the set. Copy. Returns a copy of the set. Difference. Returns a set containing the difference between two or more sets. Difference update. Removes the items in one set that are also in another specified set. Discard. Remove specified item. Set methods continued. Intersection. Returns a set that is the intersection of two other specified sets. Intersection update. Removes the items in one set that are not in the other specified sets. Is disjoint. Returns if two sets have an intersection or not. Is subset. Returns if another set contains this set or not. Pop. Removes an element from the set. Remove. Removes the element from remove the specified element. Set methods continued. Symmetric difference. Returns a set with the symmetric differences of two sets. Symmetric difference update. Inserts the symmetric differences of two sets. Union. Returns a set containing the union of sets. Update. Update the sets with the union of this set and others. Tuples. Immutable, can't be changed or mutated. Ordered, written in parentheses, round brackets. Tuple methods. Count. Returns the number of times a specified value occurs in tuple. Index. Searches tuple for a specified value and returns the position of said value. And moving on to the code walkthrough. Here's the code real fast. And as you can see, I kind of separated it up between each category, each grouping of collection. So the set code's over here, list code is all here, dictionary code's over here, and the tuple somewhere. Alright, so if you want to see ahead of time, here's what the output is going to be. So starting at the top. For the dictionary code, first print the dictionary code. That's just a little header space to help with organizing. Create the dictionary right here. So our dictionary is going to have the name character info. It's going to have the keys of name, health, and strength, and the values of Jake, 89 for health and 19 for strength. So the same way that with lists, this would be indexed at 0, 1, 2. We refer to the index. So here's the key. So whereas the index can only be referred, or the list can only be referred by index number, here you're going to refer to it by the key, which is usually going to be inside of quotation marks. So character info, name, all this stuff. Print character info, that's going to print out the whole item that we have right here, the whole dictionary. And then if we want to refer to just one item in it, we could do print just the character info and with the name. So this is the key that we're referencing, and it will refer to the value that we've given it for Jake. So if we wanted to, we could change that real fast and make it character info Jake would receive name would receive the value of Sam. Alright. And then if we were to print it, notice how right now it says value is Jake. Clear that out. And then now it should say name is Sam. So that's how you can change that up. Print the character info, name, character info, name. And then we can loop through the collections like this. So for key value in character info.items, make sure you have this part included so you can get both of these. Print the key and then the value. And that is how we got this whole little table looking thing right here. So as you can see, the name is that, health, value, and all that. So those match up to each of these. And don't necessarily rely on these being in the same order that you assigned them, because dictionaries are unordered. So they can technically appear in any order, they just happen to appear in the proper order here. So that does it for dictionary. For list code, move over to here. Alright, so print list code, Put a little space right here so it makes it look a little bit neater. Create the list. Remember that lists start at index of 0. So for the animals list, we have dog, cat, and bird, and I just added the number afterwards to help make it a little bit easier to remember what index they have starting off. So here we print the list of animals, and that's where we got this. And then we loop over them again, so print each item in the list. For animal and animals, again, remember this could be anything as long as this matches up with this. So that'll produce the exact same result. I just did animals so that it makes it a little bit easier to remember, or it's similar. But that kind of confused me a lot starting off when I saw that, and I wasn't sure if this always had to be related to this and how the computer was able to figure out, well, how is this singular and this plural and all that kind of stuff. The only thing that matters is here's the name of the list, the collection that you're going over, and this is just any variable name that just has to match up with this one. So that's how we got all this. Moving on, accessing list by index numbers. Right here you can do animals 1, and that would return you the first index, which would be the second item, because again it's 0 indexed. So, and you can also go from negative index, so you can see that right here. So that would be starting from the back. So when you're going from the negative index, the -1 would be the last item, -2 would be the previous item, and so on and so forth. So as you can see, where are we at over here? Print animals 1 here, bird 2. So yeah. Accessing a range of indexes. So if you want to access certain items from a certain point to another point and only include that part, then you access it here. So the first one is going to be your starting index inclusive, and then the second number is going to be the ending point exclusive. So right here, it's not going to include the second index. It'll only include 0 and 1, and it'll stop right before it gets to the 2. So that can be a little bit confusing starting off, but you get used to it pretty fast. So, and you can see that printed out, animal 0, 2, right here. So printed out dog and cat. So the 0 and first index. Change the value of an item. So if you access the element in the array or the list, you can change it just like you would a normal variable, because I'm pretty sure it just accesses a certain memory location, same way that you would be assigning a variable, except this happens to be a list or array. So, and if you happen to learn assembly, it makes a lot of this stuff make a lot more sense than if you're just learning it at a high level, level. But it does have its reasons that are actually pretty make sense once you actually understand how the underlying architecture and everything works. So anyways, changing the value of an item. Here we change this to that. Print a little new line to make it a little bit neater, and then print animals. And here we can see list code dog, cat, wolf. All right. So here we accessed the 0th index element, and rather than now being a dog, now we have a wolf. So that's right over here. And then we can print the length of a list, append to the end of the list, and then print the new value right here. So print, you have length animals. That's just going to return you the count of pretty much. So you can also use this not only for collections, but you can also use it for strings. So if you had a word such as animals that has 7 letters, it would return the number 7. So you can use that if you have a long bit of text that you need to know the length of for some reason, anything like that. So this one's pretty useful in a lot of situations. Print, you have length animals.append bear. So what append is going to do is it's just going to add it to the end of the list. So now it'll say you have this many animals, and if I was to print out just the animal, well, let's go with this first. So appended bear, you have this many animals. So right here after this, currently we have 3 animals, and then we get to the append bear, and it says you now have 4 animals. And if you were to print it right here, it would show this with the bear added on to the end right there. So you know this, animals.insert, you're going to insert it at this element, this value. So it'll put tiger into the third element, third index, or the 3 index, which would technically be the 4th and everything else is just going to get scooted forward. So, or backwards, however you want to view it. It will get scooted to the right, shifted to the right, however you want to call it. So, animals, insert tiger, and then now here you can see 0, 1, 2, 3. We inserted into here the value of tiger, and then bear got shifted over to the right. So, printed animals to remove items from a list. Popped animals, you can use pop, the method we went over earlier in the slideshow. So what this will just do is it's just going to remove the last item and it will return it. So not only will it remove it, but you can also assign it to a variable if you want to. If you don't assign it to something, then you don't really do much to it. I think it might go to some kind of temporary thing, but I don't know the details of that at the moment. So we pop animals into popped animals, and then after you pop the animals, this is what we're going to have. We have this. Notice how before the pop we also had the bear on the end, so we removed that, and now we have this. And then after animals.remove tiger, so this is going to remove the where it has that particular value. So we get rid of the tiger, and then we can see that tiger's been removed, and we're back to having wolf, cat, bird. And then delete animal 0, so this will just get rid of the first one. And then now we have cat and bird because we got rid of the 0 element item. Animals.clear are just going to completely clear everything after del animal 0, after animals.clear. So notice that here we have no more items. So technically the array still exists and it's still being referenced. It just, there's no items in it. And after that, we del animals, print after delete animals, we have animals. So let's see what that does. Name error, animals is not defined. Alright, yeah, so we have an error this time because we are trying to reference something which does not exist. So that's why I had that commented out. We can save that. And I do believe that when you delete the the list, you're not actually technically deleting the list. You're just dereferencing it. I could be wrong on that, but it's something along the lines of you're not really deleting it, you're just forgetting it, which leads me to believe that what you're just doing is just forgetting the memory location of where this array list happens to be stored at. So just that could be useful information at some point. So list of lists are what we covered earlier about multidimensional arrays, so are matrices, more commonly called matrices in math. So exercises, here we got push-ups, pull-ups, squats, lunges. Upper body is going to be inside of the 0 index array and then the 1 index array, and then within that we have, so this will be 0, 0, 0, 1. This one will be 1, 0, 1, 1. So here we can print exercises, and that'll just print the whole thing. And now that the error message should be gone again. Alright, so right over here, this is going to be our entire multi-dimensional list, or list of list. Exercises, exercise 1 is going to refer to this first thing right here, and you can also go more and more sub-lists if you want. Kind of hard to represent that physically at that point, but once you get like 4 or 5 or more, then it's really abstract, but you can still use it just for organizational purposes on paper. Just converting it into physical representations is a little bit more difficult. So for exercises 1, referencing the first list inside of this list, that returns this, and then here's how we access the individual item within the list, the sublist. And we can see that right there, and that's all over here. So moving on to sets. Here's what we got right here. Alright, so print the set code. A couple of new lines escaped, so that'll just print the new line. Here we create the set. Numset gets assigned this. Notice how it's inside of these little curly braces, so that indicates that it's going to be a set. Then we just fill in the values over here. Print numset, and then just a little note. Repeats automatically removed, so we can see that. Here's 1, 2, 3, 3, 2, 1. So this whole bit right here and this 2 should not appear. And as you can see right here, we removed all the repeats. So numset's automatically removed. Numset.add 100, so you can only add one item at a time. And now over here, remember that sets are unordered. Here you can see that the 100 appears in the middle, so that's what it refers to when it says unordered. So you can't rely on it being exactly where you expect it to be. Yeah. So print numset, remember the sets are unordered, and then we can update it by adding these values to it. So if you want to add one item at a time, use the add method, and if you want to add more than one value at a time, go use the update method, and here you can add many items at a time. So print numset, and again, numbers can appear in any order. So here we look right here, and notice how the 10 appears over here, the 20 is over here, and the 30 is over here. Even though we entered it sequentially 10, 20, 30, 40, they appeared in any order. So keep that in mind for sets. Dictionaries are the same way. And as for tuples, just a little standard organization right there. We're going to make a tuple called fruit tuple. It's going to contain the values of strawberry, kiwi, and orange. And we're going to print fruit tuple. So this is what it's going to look like as a whole. It's right here. So very similar to the arrays and the sets and everything else when you print the entire thing. And then if we're printing just one value, print fruit tuple 0. So this one's very similar to an array or a list. The only difference, one of the main differences, is that with the tuple you can't change it. Once you've made it, that's going to be your tuple. So, but we access it the same way as we would with a regular list. So fruit tuple 0 is going to be strawberry, the 1 index is going to be kiwi, 2 index is going to be orange. So we print fruit tuple prints the whole thing, and then print fruit tuple 0 index is going to return us with the very first item, which is going to be strawberry. And then now here we have our little fish tuple. Turn the tuple into a list, modify the list, create new tuple from the list. So that's what's going on in all this code right here. So first we create the tuple, we name it, and then we assign it these values. So blue fish, red fish, yellow fish, green fish. And then we're going to print the starting fish is fish tuple. So this is what our tuple is starting off as. Should say starting tuple. So our starting tuple is going to be blue, red, yellow, green. And then we're going to go fish list gets list. So we're going to convert this into a list so that we can modify what we have. So list fish tuple is going to just return simple array for this. And then fish list 3 gets the value of purple. So rather than this being green, it'll now be purple because 0, 1, 2, 3. And then we take this, which is now a list, fish list 3. Tuple fish list is going to be turned into a tuple, and then it's going to be assigned to fish tuple. So you can just completely override it. You just can't modify it. Or you can change the reference, I'm guessing is what's going on. So we got that, and print the finishing fish, which is going to be fish tuple. And here's our finishing fish tuple, which is going to be blue, red, yellow, and purple. Hopefully that made a lot of sense. If not, go rewatch the slides, and you can look up separately all of those methods because I don't have the time at the moment to cover every single method in detail, but you have all of them, so you can look those up. Python reference, Python docs.python.org/3, I believe. It was listed somewhere. They have pretty much all the methods for the entire Python language that comes built in, so you can go read that. Really good resource. And other than that, have a great day. Thank you very much.